AmoyDx kommt limited. AmoyDx HRD focus panel. Before watching the video, please read the instruction carefully and become familiar with all components of the kit prior to use. Strictly follow the instruction during operation. AmoyDx HRD focus panel is developed based on handle system technology. Overall, 6 main steps are required to complete library preparation. Reagents for each step are in tubes labeled with different colors. For pre-denaturation step, TE-low solution is required. For hybridization step, 2 reagents are required: probes and hybridization buffer. HRD extension ligation mixture mix is used for extension and ligation. HRD Exonuclease A and HRD Exonuclease B are used for exonuclease digestion. After exonuclease digestion, a PCR amplification step is performed to enrich the target libraries. The AmoyDx HRD focus panel provides a total of 96 combined barcodes for 96 samples parallel sequencing with 12 tubes of HRD N7 primer and 8 tubes of HRD S5 primer. It is recommended to use agent cord Ampure XBBs for library purification to remove residual extra primers and reagents. Library quantification and size distribution measurement are needed prior to sequencing. It is recommended to include a HRD positive control A in the process of library construction, sequencing, data analysis, and a no template control in the process of library construction. For NTC, it's just for quality control of the library construction process, and no need to run the sequencing or data analysis process. Materials and equipment required are thermocycler, vortex mixer, mini centrifuge, pipettes, magnetic stand, and timer. The consumables that need to be prepared are as follows: nuclease-free filtered pipette tips, 0.2 ml nuclease-free PCR tubes, waste container, 1.5 ml nuclease-free centrifuge tubes, tube racks, ice box for 0.2 ml and 1.5 ml tubes, powder-free latex gloves, mask and marker. Before starting, make sure that all reagents required are ready in place. DNA extracted from FFPE tissue samples are applicable for this testing. The freshly cut sections of FFPE tissue should be used for DNA extraction immediately. The storage time of FFPE tissue samples should be less than 12 months. It is recommended that the tumor cell content is not less than 30%. After the extraction, measuring the concentration of extracted DNA, the DNA concentration should be more than 6.25 nanograms per microliter, and the total DNA should be more than 50 nanograms. The optimal DNA input for HRD testing is 100 nanograms per sample. It is recommended to recollect the samples or re-extract DNA if the sample does not meet the above requirements. Take out the DNA samples, HRD positive control A, and TE-low solution, and thaw the reagents at room temperature. When the reagents are completely thawed, vortex each tube for 5 to 10 seconds and centrifuge briefly. Then put them on the tube rack. Please note that the laboratory needs to prepare TE-low solution in advance. Prepare the pre-denaturation solution in the 0.2 ml PCR tube according to the table on the left. For FFPE samples, X stands for the volume of 50 to 100 nanograms DNA. For positive control, the DNA concentration of HRD positive control A is 6 nanograms per microliter. Take 8 microliter to construct library, X equals to 8. For NTC, use the TE-low solution of 8 microliters, X equals to 0. Mix the solution thoroughly by vortexing and centrifuge briefly. Then place the tubes into the thermocycler. Set the reaction volume as 8 microliters and perform the following program. 98 Celsius degree for 5 minutes, then put the tubes on the ice immediately. Take out the HRD probe and HRD hybridization buffer and thaw the reagents at room temperature. When the reagents are completely thawed, vortex each tube for 5 to 10 seconds and centrifuge briefly. Then put them on the ice box. Take out the pre-denaturation tubes from step 1 from the thermocycler. Put them on the ice box and add 1 microliter HRD probe and 1 microliter HRD hybridization buffer. Mix the solution thoroughly by vortexing and centrifuge briefly. Then place the tubes into the thermocycler. Set the reaction volume as 10 microliters and perform the following program: 95 Celsius degree for 5 minutes, 60 Celsius degree for 2 hours, hold at 4 Celsius degree. Take out the HRD extension ligation master mix and thaw the reagent at room temperature. When the reagents are completely thawed, vortex each tube for 5 to 10 seconds and centrifuge briefly. Then put them on the ice box. Take out the above PCR tubes from the thermocycler, centrifuge briefly, and put them on the ice box. Add 1 microliter HRD extension ligation master mix into the PCR tubes. Mix thoroughly by vortexing and centrifuge briefly, and then place the tubes into the thermocycler. Set the reaction volume as 11 microliters and perform the following program: 60 Celsius degree for 10 minutes, hold at 4 Celsius degree. Take out the HRD Exonuclease A and HRD Exonuclease B. Vortex each tube for 5 to 10 seconds and centrifuge briefly. Then put them on the ice box. Take out the above PCR tubes from the thermocycler, centrifuge briefly, and put them on the ice box. Add 1.5 microliters HRD Exonuclease A and 1 microliter HRD Exonuclease B into the tube. Mix the solution thoroughly by vortexing and centrifuge briefly. Then place the tubes into the thermocycler. Set the reaction volume as 14 microliters and run the following program: 37 Celsius degree for 30 minutes, 95 Celsius degree for 10 minutes, hold at 4 Celsius degree. Take out the HRD N7 primer, HRD S5 primer, and HRD PCR master mix and thaw the reagents at room temperature. Then the reagents are completely thawed. Vortex each tube for 5 to 10 seconds and centrifuge briefly. Then put them on the ice. Take out the above PCR tubes from the thermocycler and put them in the ice box. Add 25 microliters HRD PCR mixture mix, 1.5 microliters HRD S5 primer, and 1.5 microliters HRD N7 primer into the tubes. Mix the solution thoroughly by vortexing and centrifuge briefly, then place the tubes into the thermocycler. Set the reaction volume as 50 microliters, then perform the following program according to the table on the right. Take out the AMpure XPBs and equilibrate them to room temperature for at least 30 minutes before use. Prepare an 80% ethanol solution by combining 1 part molecular-grade water and 4 parts molecular-grade ethanol. Vortex the bottom of the beads for 1 minute to resuspend any magnetic particles that may have settled. Add 37 microliters beads into 1.5 milliliter centrifuge tubes. Take out the above PCR tubes from the thermocycler. Mix the solution thoroughly by vortexing and centrifuge briefly. Please accurately transfer 40 microliters PCR products into 1.5 milliliter centrifuge tubes. Mix thoroughly by vortexing, then incubate the mixture at room temperature for 5 minutes. Place the centrifuge tubes onto the magnetic stand for 3 to 5 minutes until the solution turns clear. Gently remove and discard the supernatant while the centrifuge tube is on the magnetic stand. Do not touch the beads with the pipette tip. Keep the tubes on the magnetic stand. Add 200 microliters freshly prepared 80% ethanol into the centrifuge tube and keep it at room temperature for at least 30 seconds. Remove and discard the supernatant while the tube is on the magnetic stand. Repeat the washing step with 80% ethanol once. Air dry the beads for 2 to 3 minutes while the tube is on the magnetic stand with the lid open. Elute the samples when the beads dried briefly. The surface takes on a matte appearance. Do not over-dry the beads. This may result in a lower recovery of DNA. Remove the centrifuge tubes away from the magnetic stand. Add 20 microliters TE-low solution. Mix thoroughly by vortexing. Then incubate the mixture at room temperature for 3 minutes. Place the tube onto the magnetic stand for 3 to 5 minutes until the solution turns clear. Transfer the supernatant into a new 1.5 milliliter centrifuge tube to obtain the DNA library. Do not touch the beads with pipette tip. Quantify the DNA library concentration using Quantas or Qubit fluorometer. The DNA concentration should be more than 20 nanograms per microliter. If not, the library is unqualified. If the library concentration is less than 20 nanograms per microliter, the original DNA may be of poor quality. The DNA concentration may be inaccurate or there may be operational errors during the experiment. The DNA concentration should be retested and the DNA libraries should be reconstructed. For poor DNA quality sample, up to 200 nanogram of DNA input is recommended. Quantify the DNA library fragment size using Agilent 2100 bioanalyzer system and Agilent DNA 1000 kit. The main peak of the DNA fragment size should be at 230 to 330 BP if the anti-seed library detects the target length fragment. There may be contamination during the experiment, and the experiment should be repeated. If the library passes the qualification standards, it is ready to sequence now. Perform the denaturation and dilution of the libraries according to the instrument's instructions. The final concentration of sequencing library is recommended in according to the table below. AmoyDx Diagnostics Company Limited